Okay, so we're going to take a quick look at the cosine waves, which I did mention to you guys that the sine and the cosine, that's the complement sign. So it's just really a shift by 90 degrees effectively between the two. So the waves are going to look very, very similar. So just like we did on the last one, let's go over to here and just build the basics. So on basics, a cosine, remember the cosine of theta was the x value on the unit circle. So when I start with a cosine, you'll notice that when I try to take the cosine of 0, I get 1. So that's sitting right here. And the cosine, by the time I reach pi over 2, is dropped down to 0. And by the time I reach pi, it's gone all the way down to -1. 3 pi over 2, the cosine x value became 0 again, and by 2 pi it's reached back to 1, and then it repeats that process again for all eternity because it's a periodic wave. So just like the other one, it looks like this. And what you should notice if we look at it is although it doesn't look exactly like the cosine wave, the sine wave, excuse me, this is my fundamental piece of the cosine wave. It starts at the top and ends back at the top. But if you were able to continue this process just a little bit, you would notice that what looked like a sine wave before exists. If I hold this right here, I think we can see that together. You'll notice that if you started here and you ended here, that would be a sine wave. From here to here is a sine wave. But we're just going to shift it over just a little bit. And so what I'm going to do is I'm going to consider A, my starting value 0, 1, and my ending value to be 2 pi comma 1. And keep in mind that in the middle of these two values, A and B, there's always this value down here that's right in the middle that of A and B horizontally, but at the bottom it goes to its minimum, and right in the middle of those two is where it hits the middle. So that's kind of what we're going to do. I'm going to start with -2 because that is the middle line of this thing. The thing got shifted down 2 units. It's got an amplitude of 2, so I'm going to go up 2 and down 2 from there. And if I could just generate a couple of points, then I'll have it. So let's see. Let's start off here. I'm going to take my y value, I'm going to double it in 2 and go down 2, and that gives me 0. Similarly over here, since it's the same starting value, it's going to have the same result. And inside, I'm going to take the x value, and I'm going to do the opposite of what it says, and I'm going to take 0 and subtract pi over 2. So at negative pi over 2, which is right here, I would have a height of 0. That's my new A. And over here, if I took 2 pi, also known as 4 pi over 2, and I move to the left, I would be at 1 left, which is 3 pi over 2, right here. 2 pi over 2, 4 pi over 2, so that's 3 pi over 2. And like we said, right in the middle of these two top values should be a middle all the way at the bottom. And in the middle of these two values should be somewhere at that equilibrium or that middle line. And so we kind of have what our cosine wave looks like. And like we said in the previous video, we usually go ahead and plot at least 2 periods of it so we can copy a couple of pieces down, just kind of following the pattern that exists. And so here would be another one right here. And there we go. And something that's of note is if all somebody was doing is, say, looking at your picture, there's no way to tell if this is the graph of a sine wave or a cosine wave because they literally look the same. It's just sort of what piece you're looking at. Like if I started looking right here, that looks perfectly like a sine wave, but if I looked right here, it looks like a cosine wave, and actually we haven't done that yet. This one actually just looks like a cosine wave flipped over, which is a negative cosine wave, and we'll be doing all those things. So last one. The last cosine wave that I have is this guy right here. So again, if we started at our introductory value 0, 1, I'm going to double that y value and then add 1. So that would be 1 doubled is 2, add 1 is going to be 3. And now we're going to take this value, remember insides attack x, and they do the opposite. So 0 is going to get divided by 2, which of course stays 0, and then I'm going to add 3 pi over 4. So that's going to be my new A. And 2 pi comma 1, we know it's going to end at the same place as this one because it was periodic and also we're modifying the same value. So I'm going to take the 2 pi right here, I'm going to divide it by 2, which gives me pi, but I'm going to write that as 4 pi over 4, so I have a common denominator. Remember, 2 pi divided by 2 is pi, and then I need to add 3 pi over 4 because it's going to scoot to the right that far. And so I think we're ready to go. So I'm going to put a little dotted line at 1 because it got shifted up 1 unit. That's where the x-axis used to be. It's got an amplitude of 2, so I'm going to go up 2 and down 2. So the wave is going to come up and down, alternating between those lines. And so A prime was 3 pi over 4. That's 1, 2, 3 pi over 4, comma 3 right there. It's going to end at 7 pi over 4. So here is 8 pi over 4. So 7 would be here. So here's my new A, my new B. We said C was going to be right in the middle, which should be right here. And right in the middle of those two should hit in the middle. And so you'll notice this wave looks like it goes really, really fast, doesn't it? And that's because not only is it scrunched this way, its period is smaller, but it's also taller. So it's harder to make these waves look good because it's moving so much more rapidly than the other ones. Like literally every pi over 4, it's moving very, very quickly. And hopefully I did this all right. And that should be sufficient to do a pretty nice looking wave. And again, the primary wave for this particular one is here. And there we go. That's how we graph cosine waves, at least for the moment. And tomorrow in class, we're going to do something that's going to hopefully make that a little bit easier for you. Okay, I'll see you in class soon.